Hello and welcome. We are discussing PYQs of number system and the theme is classification of numbers. Now we know that numbers are classified into a lot of categories. For example, natural numbers. What are they? All counting numbers are called natural numbers like 1, 2, 3, 4 and so on. Okay, then there comes whole numbers. So in whole numbers we include 0 also. So 0, 1, 2, 3 and this goes on are what? Whole numbers. Then there comes integers, in which we include their negative parts also, like minus infinity to minus 3, minus 2, minus 1, 0, 1, 2, 3 and so on. Now remember, whether we talk about natural number or we talk about whole numbers or we talk about integers, they are complete numbers. In these three categories, we do not include any fraction, we do not include any decimal. They are fraction and decimal free. Then to include fractions and decimals, there are two more categories. One out of them is rational numbers, right? So the numbers that can be represented in the form of PYQ, okay, where Q should not be equal to 0 and P and Q both must belongs to what? Integers. And then there are irrational number like pi. Okay, irrational numbers are those numbers that are not rational. Okay, so I hope you have a fair idea about all these classification. So let's try to solve some problem based upon their nature and their classification. So this is the question number 1 that was there in the year 2024. It says three numbers x, y, z are selected from the set of first 7 natural numbers. Now, what are natural numbers? All counting numbers that starts from what? 1. Over here we are talking about first 7 natural numbers. So first 7 natural numbers are 1, 2, 3, 4, 5, 6 and 7. And x, y and z, x, y and g must belongs to these 7 numbers only. It has been stated in the statement of the question. Next statement says such that now the value that x, y and z can take, it must be in such an order that should justify this given inequality. X should be greater than 2y and 2y should be greater than 3z. So how many such distinct triplets x, y, g are possible? Okay, let's try to understand this. So we have to assume a value for x, a value for y, a value for z out of these 7 values only. And 3z must be the smallest quantity. So assume the smallest number that you can assign to z. See, from 1 till 7, the smallest number that we can assign to z is 1. Z is 1. If your z is 1, then 3z will become 3 into 1. Now we have to pick such a value of y which when multiplied by 2 should be greater than 3. So let's, by hit and trial, let's assign next small, after 1, next smallest value to y. After 1, next smallest value to y, that is 2. So if your y is 2, it becomes 2 into 2. So 2 into 2 is what? 4. And 3 into 1 is what? 3. Now, out of these 7 values, x can take any such value which is greater than 4. Okay. So if you can consider x to be 5 here. So first such triplet gonna be 5 to 1. You can consider x to be 6 here. So next such triplet gonna be 6 to 1. You can consider x to be 7 here, because whether you consider x to be 5 or x to be 6 or x to be 7, these values will justify our given condition. So 5 to 1, 6 to 1. Okay. The values of x, y, g, 5 to 1, 6 to 1, 7 to 1. So we can clearly see presence of the 3 triplets. Done. Now, is it possible to assign value 2 to z? Is it possible? Let's check it out. Suppose if z is 2, or rather than this, let's finish off y first. Consider z to be 1 again. We have considered y to be 2. Now, is it possible to consider any other value for y here? Let's check it out. Y is 2. Let's say y is 3 now. So 3z will become 4 for z to be equal to 1 and y to be equal to 3. For z to be equal to 1 and y to be equal to 3, 3z will become 3, 2y will become 6. So x can take any value out of these 7 which is greater than 6. So only one value is present which is greater than 6, which is 7. So the next triplet that is possible here is what? 7, 3, 1. So till now, how many triplet I got? 4 triplet. And out of these given option, the maximum possible option is 4 triplet. Hence, it is the right choice. Okay, I hope guys you have understood it. Let's move on. Please note it down. Next question. Consider the following statement in respect of sum s. Value of sum is s, and in this sum we have x, we have y, we have z, where x, y, z are distinct prime numbers less than 10. Now, what are prime numbers? The numbers that are having only 2 factors, 1 and the number itself. For example, 17. 17 is divisible by only 2 number, which is 1 and 17 only. Hence, 17 is what kind of number? Prime. For example, 2. 2 is also a prime number because it is divisible by 1 and 2 only. 2 is having only 2 factors. Okay. So, in this question, examiner is saying that x, y, g are all prime number that are less than 10. So less than 10, first prime number is 2, second is 3, then there is 5, then there is 7. Meaningly, then there is 7. So x, y, z, x can take 2 as a value, 3 as a value, 5 as a value, 7 as a value. Y can take 2 as a value, 3 as a value, 5 as a value, 7 as a value. Z can take 2 as a value, 3 as a value, 5 as a value, and 7 as a value. Only 4 values are possible for these 3 different numbers. Okay. Now, so we are interested in calculating S. We are interested in calculating S. So let's check it out. See, X can be 2, Y can be 3, Z can be 5. X can be 2, Y can be 3, Z can be 7. Okay. Okay. Next, X can be 2, Y can be 5, Z can be 7, and X can be 3, Y can be 5, and Z can be 7. So see, out of these 4 numbers, I have to select only 3 numbers. Out of these 4, we have to select only 3. So only these 4 possibilities are present. What is S? S is sum of 3 selected numbers. What is S? S is the sum of 3 selected numbers. Okay. So now, whether you say, in this case, you can also go like this as well. It is over here you have considered X to be equal to 2. So you can consider, in this case, you can consider X to be equal to 3, Y to be equal to 2, and Z to be equal to 5 also. We are not concerned with their order. We are not concerned with their order. We just need 3 different numbers. So out of these 4 different numbers, these are the 4 possible ways to find out to find out 3 different numbers. Okay. Now, what is S? S is the sum of the selected number. So 2 plus 3 plus 5 is what? 10. 2 plus 3 plus 7 is what? 12. 2 plus 5 plus 7, 14. 3 plus 5 plus 7, 15. So where X, Y, Z, so done. Now, the unit digit of S can be 0. Yes. For this particular case, the unit digit is what? 0. What is S? Sum of these 3 digits. So unit digit 0 is possible. So statement 1 is right. The unit digit of S can be 9. Can you see unit digit 9 anywhere? No. So this is not possible. Unit digit of S can be 5. Yes, 5 is also visible. So statement 1 and statement 3 are the correct options, are the correct statement. Hence, option C is the right choice here. I hope guys this is clear to everybody. Please mark it, understand it. Let's move on to next problem. Okay. Now, this is a very unique case, and every year there are problem on even and odd number. So we need to remember some points here. Okay. I hope you are well aware of these points, but let me discuss these points one more time. The point is, if you add any 2 even numbers or you subtract any 2 even number, your result is always even. If you add or subtract any odd number from an even number, your answer is always odd. If you add or subtract any even number from an odd number, again your answer is always odd. If you add or subtract any 2 odd number, your result is always even. If you multiply an odd number with an even number, your result is always even. Now, I hope you know what are even numbers. The numbers that are completely divisible by 2. What are odd numbers? The numbers that are not completely divisible by 2. For example, 16. 16 is completely divisible by 2. Hence, 16 is what kind of number? Even number. And 17 is not completely divisible by 2. Hence, 17 is odd number. Okay. Now, The statement says let P, Q, R and S be distinct positive integer. What are positive integers? 1, 2, 3, 4, 5 and so on. All these numbers are called what? Positive integers. Remember, integers is present, so integer do not include any fraction, integers do not include any decimal. Now let P, Q be odd, okay, and R and S be even. Then consider the statement. See, Q and S, I know S is even, I know what S is even. Now even number multiplied by any number will always produce an even number in the result. You multiply an even number with odd number. For example, 7 is odd, 2 is even. Your result will always be even. You multiply even number with any kind of number, your result will always be even. So in this case, S is being multiplied with Q, and with this expression I know S is even, it is given. S is even, hence this is true. Second is true also, because S is what kind of number? Even number. Even number multiplied with any term, any fraction, even number multiplied with any number will always produce even number in the result. Will always produce even number in the result. So this is also correct. Now the last expression is Q plus R square into P plus S. What kind of number Q is? See, Q is odd. What kind of number R is? R is even. What kind of number P is? P is odd. What kind of number S is? S is even. Now see, odd plus even will produce odd number in the result. Square into odd plus even will produce odd number in the result. See, odd plus even. Odd is 7. 4 is even. 7 plus 4 is 11. 11 is what? If you add an odd number to an even number, your result is always odd. You add odd number to even number, your result is always odd. Okay. Now, if you square an odd number, your result is always odd. O over here stands for odd. You 3. 3 is what kind of number? Odd. If you do 3 square, result is 9. 9 is what kind of number? Odd. Now, odd when multiplied with odd, the result is always odd. Hence, the statement 3 is also correct. The right choice of this question is option D. I hope guys you have understood it. So, this is it for the video. We'll meet you in the next. Till then, please take care and bye-bye.